Hello students. So today we will do atomic structure question part 4. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in the deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So what are we going to do today? So we are going to practice question from 28 to 36. That is total of 9 questions. So let us start it. Question number 28. Question number 28 says that the radius of the second Bohr orbit for hydrogen atom is Planck's constant value is given, h is equals to 6.6262 into 10 to the power minus 34 joule second. Mass of electron is given 9.1091 into 10 to the power minus 31 kg. Charge of electron is given 1.60210 into 10 to the power minus 19 coulomb, and permittivity of vacuum is given 8.854185 into 10 to the power minus 12 per kg per meter cube A square. Options are A 1.65 in angstrom, option B 4.76 angstrom, option C 0.529 angstrom, and option D 2.12 angstrom. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. The question says that it is asking you to calculate the radius of second Bohr orbit for hydrogen atom. Okay, so this is being asked to calculate. Now the various constant value that you will require are given. So Planck's constant value, mass of electron, charge of electron, permittivity, all these values are given. So the answer will be, so first of all, the answer will be D, which is 2.12 angstrom. What will be the explanation to do so? So we know that the Bohr radius is given by Rn is equals to n square h square by 4 pi square me square kz. Okay, where k is equals to 1 by 4 pi epsilon naught. Now, if you put all these values here, then you will get this formula which is n square a naught by z. So what are the things that you have to put? So this is basically h is your Planck's constant, e naught is your say permittivity, pi is simply a constant, mass is mass of electron, E is charge, Z is atomic number, n is what? N is your orbit number. Now what we have done is we have taken this n square and Z out, and rest of this these two things can vary, and rest of the things are taken as constant, and it is equals to A naught. Clear? Okay. Moving to the solution further. So same thing is mentioned here. M is mass of electron, E is charge of electron, H is Planck's constant, K is Coulomb constant. Therefore, Rn is equals to n square into 0.53 by z. So if you calculate that A naught, you will get this thing as 0.53. Now the radius of nth orbit for hydrogen atom will be how much? So since for hydrogen atom z is equals to 1, therefore the nth orbit radius will be 0.53 n square angstrom, where z is equals to 1 for hydrogen atom. So for second orbit of hydrogen atom, what will be the formula? It will be 0.53 into n square, which is 2 square, and can be written as 2.12 angstrom as your final answer. Clear? So in this way you will calculate this. Now moving on to the next question. Question number 29. Question number 29 says that the kinetic energy of an electron in the second Bohr orbit of a hydrogen atom is, where A naught is what? A naught is a Bohr radius. Options are A h square by 4 pi square ma A naught square, B h square by 16 pi square ma A naught square, C h square by 32 pi square ma A naught square, option D h square by 64 pi square ma naught square. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. The question says that you have to find the kinetic energy of an electron. Okay, which electron is where? That electron is where? It is in the second orbit of the hydrogen atom. And A0 is the Bohr radius, it is already given. The correct answer will be C, h square by 32 pi square ma naught square. How will solve it? Let us see. So according to your Bohr's model, we know that mvr is equals to nh by 2 pi. Means your angular momentum is always an integral multiple of h by 2 pi, where n is what? Is it is an integer, right? So further, if you just put this thing here, okay, we have taken square here. We have taken square on both sides. So that will result in mv square. We have put moved this r here, so that is resulting in r square here. So mv square is equals to n square h square by 4 pi square r square. Now we know that kinetic energy is what? It's equals to half mv square. So we have calculated the value of m square v square. Therefore, we can write mv square is equals to what? Mv square is equals to n square h square 8 pi r square by m. Because this is m square v square, but we have to find it for mv square. So we have cross multiplied this m here, and this is the kinetic energy formula. Further, we need this radius. So radius of an nth orbit of this hydrogen atom is given by a0 multiplied by n square z. Now a0 is what? A0 is your Bohr radius, which is already given. Now for hydrogen atom z is equals to 1. So this equation becomes, so if you just put this r value in the equation 1, it will become h square by 8 pi square n square a0 square by a0 square m. So we have taken z is equals to 1 and we have calculated r, and just we have back substituted this r value in the kinetic energy equation. So we have to calculate with the second orbit, so n is equals to 2. Therefore, your kinetic energy will be how much? H square by 8 pi square 2 square a0 square m, which is finally h square by 32 pi square a0 square m, where m is what? M is your mass. Clear? The particle that we are dealing with. So this was our solution. Now moving on to the next question. Question number 30. So question number 30 says that the de Broglie wavelength of a car of mass 1000 kg and velocity 36 km per hour is h is equals to 6.63 into 10 to the power minus 34 joule second. Options are A 6.626 into 10 to the power minus 34 meter. Option B 6.626 into 10 to the power minus 38 meter. Option C 6.626 into 10 to the power minus 31 meter. Option D 6.626 into 10 to the power minus 30 meter. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution, how we can solve it. First of all, you have to find the de Broglie wavelength. Okay, so you will use the formula lambda is equals to h by mv to do this, and other all values are given, like your mass and your velocity, and h value is also given. For those who have solved the question, this answer will be B 6.626 into 10 to the power minus 38 meters. So this will be your answer. Now we know that the de Broglie equation is what? Lambda is equals to h by mv, where lambda is your wavelength. Okay, mv is your mass, v is your velocity, h is your Planck's constant. So it is already given that mass is 1000 kg and velocity is 36 km per hour. But your SI unit for say time is second, and all of the value that we know, which is your Planck's constant and all are in second. So rather than your answer is also required. So your answer is invariant of say of time. Anyways, but still to do this tedious calculation of converting this thing to hour might be difficult. So we use this simple thing in which we convert this hour into second, right? And kilometer into meter also. So these two things are to be done. So kilometer into meter simply multiplied by 1000. So that will give you what? That will give you a meter. Now this hour is in the denominator, and 1 hour is equal to 60 into 60 seconds. So therefore, we have divided this thing by 60 into 60. So 36 into 1000 by 60 into 60, that will give you 10 meter per second. So this is the velocity. Okay, this is what? This is your velocity. Now in putting these values in the de Broglie equation, which is lambda is equals to h by mb. Mass is will have the same SI unit, which is kg in kgs also only. But your velocity will be now in meter per second. So 10 meter per second. So putting all these values here, so this will be minus 34. So there are 4 zeros, so 34 will be added here. Hence 6.626 into 10 to the power minus 38 meter will be your correct answer. Okay, so in this way you will solve this question. Now moving on to the next question. Question number 31. Question number 31 says that a stream of electrons from a heated filament was passed between two charged plates kept at a potential difference VESU. If E and M are charge and mass of electron respectively, the value of h by lambda, where lambda is wavelength associated with electron wave, is given by options A 2 mega electron volt, or you can say MeV. B, sorry, this is not mega electron volt, this is mass EV. Okay, mass into electron volt. Option B, root under MeV. Option C, root under 2 MeV, and option D, MeV. Now you have 10 seconds to solve this question. Your time starts now. Okay. Now let us see the solution, how we can solve it. So first let us try to understand this question. What is this question all about? So what we are doing, we are streaming our electrons from a heated filament, and this streamed electron are now been passed between two charge plates. Okay, and these two charge plates have a potential difference of 4 electrostatic units. Now if E and M are the mass and charge of electron, then what will be the value of h by lambda? So this we have to find. What will the value of h by lambda? The answer is root under 2 MeV. So how will solve it? Now in the option we can see that the energy term which is mentioned is between h by lambda and E. Okay, so we have to find a relation between h by lambda and E. So for this we will use the de Broglie wavelength and kinetic energy term in electron volt. So de Broglie wavelength for an electron is given by h by P. We know that very clearly. Further, P is equals to h by lambda. We can write it. So if we are moving on to the solution further. So kinetic energy of an electron is electron volt, and also we know that kinetic energy can be written as P square by 2m. That is the momentum square by 2m. Now if you put this P value here, you will get EV is equals to root under 2 MeV. Here is the final answer. No, sorry, 2 MeV is your kinetic energy. So from equation 1 and 2, we can write h by lambda is what? Root under 2 MeV. Clear? Okay. Now moving further. Question number 32. Question number 32 says that the uncertainty in the position of an electron moving with a velocity of 300 meter per second along with accuracy of 0.001% is, options are A 3.84 into 10 to the power minus 2 meter, option B 5.76 into 10 to the power minus 2 meter, and option C 1.93 into 10 to the power minus 2 meter, and option D 19.3 into 10 to the power minus 2 meter. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve this question. So first of all, your uncertainty of the position whose velocity is already given is measured with an accuracy of 0.001%. Now if you solve it, it will have an answer of 1.93 into 10 to the power minus 2 meter. Let us see. So we know that lambda x dot lambda v is greater than or equals to h by 4 pi m. So we have simply derived it from the uncertainty principle. Okay, where we have the momentum and the position. Instead of your momentum, we have put here mv. But since mass is not having confusion or is not under some confusion, so we can take this m out of the delta and we can just cross multiply it here so that delta x dot delta v is greater than or equal to h by mv. Sorry, h by 4 pi m. Or we have to calculate what? We have to calculate delta x. Accordingly, we'll put this here h by 4 pi m delta v. If you put all these values here, h is what? H is your Planck's constant, 4 is constant, pi is 3.14 or 22 by 7, m is mass of electron, delta v is already given, which is 0.01% of what? 300. So we've done the same thing, 0.01% of 300. So this will give you 1.93 into 10 to the power minus 2 meter. So this will be your uncertainty in position. Okay, moving on to the next question. Question number 33. Question number 33 says that a dust particle has a mass equals to 10 to the power minus 11 gram. Diameter is 10 to the power minus 4 centimeter and velocity is 10 to the power minus 4 centimeter inverse. The error in measurement of velocity is 0.1%. What will be the uncertainty in position? Options are A 0.527 into 10 to the power minus 10 meter. Option B 5.27 into 10 to the power minus 9 meter. Option C 0.527 into 10 to the power minus 15 centimeter. And option D 0.527 into 10 to the power minus 9 centimeter. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see how we'll solve this question. So first of all, the mass of a dust particle is given 10 to the power minus 11 gram. And its diameter is also given, which is 10 to the power minus 4 centimeter. In addition to that, we have the velocity, which is 10 to the power minus 4 centimeter inverse. Now we have to, the measurement of velocity, means error in measurement, is given as 0.1%. So you have to find the uncertainty position. Very simple. For those who have solved, the correct option is 0.527 into 10 to the power minus 9 centimeter. Now, this is V, which is 10 to the power minus 4 centimeter second inverse velocity. And delta V is how much? It will be your 0.1% of 10 to the power minus 4 by 100. Okay, so this is your what? This is your delta V. So that will give it 1 into 10 to the power minus 7 centimeter inverse. Now we already know that delta x dot delta V is equals to lambda by 4 pi m. Okay. Or we can write delta x is simply is equals to 6.626 into 10 to the power minus 27. 4.4 into 3.14, 10 to the power minus 11 into 10 to the power minus 7. So that will give you delta x value as 0.527 into 10 to the power minus 9 centimeter as the correct answer. Clear? Okay. Moving on to next question. Question number 34. Question number 34 says that the uncertainty involved in the measurement of velocity of an electron within a distance of 0.1 angstrom is. Options are A 5.79 into 10 to the power 8 meter per second. Option B 5.79 into 10 to the power 5 meter per second. Option C 5.79 10 to the power 6 meter inverse. Sorry, 10 to the power 6 meter per second. And option D 5.79 into 10 to the power 7 meter per second. Now let us have 10 seconds to solve this question first of all. Okay, now let us see how we can solve it. So the question says that we have to see the uncertainty in measurement of velocity of electron if its distance is given as 0.1 angstrom. Now the correct option is C, which is 5.79 into 10 to the power 6 meter per second. And we know that delta V dot delta x equal to h by mv, which is delta x multiplied by delta p. Very simple. You can do this. Or we can write delta V in this form also, h by 4 pi m delta x. If you put these values all along, 9.1 10 to the power minus 31, 0.1 in 10 to the power minus 10. Okay. Then if you just calculate this thing, it will give you 5.79 into 10 to the power 6 meter per second as your correct answer. Okay. Now this question is over. Moving on to the next question. Question number 35. Question number 35 says that in an atom, an electron is moving with a speed of 600 meter per second with an accuracy of 0.005%. Certainty which the position of the electron can be located is H is 6.6 into 10 to the power minus 34 kg meter square per second. Mass of an electron is given 9.1 into 10 to the power minus 31 kg. And your options are 1.52 into 10 to the power minus 4 meter. Option B 5.10 10 to the power minus 3 meter. Option C 1.92 into 10 to the power minus 3 meter. And option D 3.84 into 10 to the power minus 3 meter. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So it is being given that the velocity of electron is 600 meter per second and its accuracy is also given 0.005%. So you have to see that what is the certainty in position, and given your Planck's constant as 6.6 into 10 to the power minus 34 kg meter square per second and your mass of electron as Em is equals to 9.1 into 10 to the power minus 31 kg. So if you have solved it, you will get the answer as C 1.92 into 10 to the power minus 3. Let us see the solution. Let us now see the solution. So by Heisenberg uncertainty principle, we know that delta x into delta p is equals to h by 4 pi or delta x into m delta v, because mass is known with certainty, uncertainty is there in the velocity. So we have put this momentum, we have substituted the momentum by mv and we have taken mass as accurate. So we can write this thing as equals to h by 4 pi, or delta v is how much? It will be 600 into 0.05 by 100. So this is your delta v, because this is the accuracy that is given. So we have taken 0.005% of 600. That will give you 0.003. So this is your delta v. Now putting this value here, so delta x multiplied by 9.1 into 10 to the power minus 31, which is mass, and delta v, which is 0.003. Okay, this is equals to h by 4 pi. Therefore, 6.6 into 10 to the power minus 34 by 4 into 30.14. So that will be further calculated for delta x. If you cross multiplied it here, and your answer will be 1.92 into 10 to the power minus 3 meter. So this will be your correct answer. Okay. Now moving on to the next question. Question number 36 says that amongst the following set of quantum numbers, the impossible set is. Your options are A, n is equals to 3, L is equals to 2, m is equals to minus 3, s is equals to half. Option B, n is equals to 4, L is equals to 0, m is equals to 0, s is equals to 1 by 2. Option C, n is equals to 5, L is equals to 3, m is equals to 0, and s is equals to what? Minus 1 by 2. And option D, n is equals to 3, L is equals to 2, m is equals to minus 2, and s is equals to half. Here n is principal quantum number, L is azimuthal quantum number, m is what? Magnetic quantum number, and s is your spin quantum number. So all these values are given. So let us see. So before that, you have 10 seconds to solve this question. Okay, now let us see the solution, how we'll solve it. So we have to find the impossible set. So the correct option is A. How we'll solve it? So for each value of L, we know that M can have value from minus 1 to plus L. So suppose if you have written L is equals to 2, then it can be, how many values can be possible? 5 values, first of all, that is 12 plus 1. And those values will be how much? Minus 2, minus 1, 0, 1, 2. So these are the 5 values that we can have. Okay, but it is given that m is equals to minus 3, which is not a possible value for L is equals to 2. Okay, so this thing is not possible. Therefore, Your correct option is A, right? Your correct option is A. Okay, so we have completed this question also. Thank you.